So welcome to my channel, and today I will discuss about the electronic transition, that is the sigma to sigma star transition, pi to pi star transition, and n to pi star transition, and n to sigma star transition. So let's start. In previous lecture, we discussed there are 4 transitions occur in molecule. That is sigma to sigma star transition, then pi to pi star transition, n to sigma star transition, and n to pi star transition. These 4 transitions are occur in a molecule. That is, these 4 electronic transitions are occur in a molecule. So at first we discuss the sigma to sigma star transition. Sigma to sigma star transition. Sigma to sigma star transition occurred in molecule that only present a sigma bond. That, for example, in methane, CH4, the structure of methane CH4. So there are 4 sigma bond, and there does not present any type of pi bond or non-bonding electron. So here only sigma bond. So here the sigma to sigma star transitions are occurred. So sigma to sigma star transition occurred only when they are present sigma bond. Okay. So example, alkane. Okay. So in alkane there are only sigma bond present, that is saturated hydrocarbon. Saturated hydrocarbons are occurred sigma to sigma star transition. Next is pi to pi star transition. Pi to pi star transition. So pi to pi star transition, the molecule in which the pi orbitals are present, the pi to pi star transitions are occurred. That, for example, CH2 double bond CH2. The structure of this molecule, that is ethene, H double bond C H. In this molecule, this is the sigma bond, this is the sigma bond, this is also sigma, this is also sigma, and here 2 bonds are present. Here one bond is sigma bond and one bond is pi bond. So in actual that also sigma to sigma star transition occurred, but here pi bond also present. So pi to pi star transitions are occurred. Here one question is come that sigma to sigma star transition are occurred or no. The answer is no. Here only pi to pi star transition occur, because the energy difference between sigma to sigma star transitions are very high, and pi to pi star transition is low than sigma to sigma star transition. So the molecule in which only sigma bond are present, there only the sigma to sigma star transition. If there have other opportunity like pi to pi star, n to sigma star, n to pi star, so these transitions are occurred. So the molecules having pi bond and pi to pi star transition are occurred. That, for example, alkene, alkyne, that is, these two are unsaturated hydrocarbon, and aromatic ring, molecule having aromatic ring present, there also pi to pi star transitions are occurred. Okay. Next is N to sigma star. Next is N to sigma star transition. So N to sigma star transitions are occurred where the N, that is the non-bonding electrons, are present. So molecules like CH3OH. So the molecule in which the sigma bond and non-bonding electrons are present, there the N to sigma star transitions are occurred. In this molecule, methanol, here in oxygen molecule, 2 non-bonding electrons are present. These non-bonding electrons are jumps from non-bonding molecular orbital to antibonding sigma orbital. So this molecule and molecule like CH3Cl, CH3I, these type of molecules are so into sigma star transitions. Okay. So alkyl halide, ethanol, methanol, that is organic alcohol, that are also occurred into sigma star transitions. Okay. Next is N to pi star transition. N to pi star transition. So the N to pi star transition occurred. N to pi star transitions occurred, not double star. Sorry. N to pi star transition occurred. The molecules having N orbitals and also present pi orbital. That is N, that is non-bonding electrons present, non-bonding electrons present, and pi bond also present. So non-bonding electrons present and pi bond also present. These molecules are shows N to pi star transitions. Okay. These are the 4 transitions of electrons. Among these 4 electronic transitions, the 3 electronic transitions are allowed transitions and 1 electronic transitions are forbidden transition. N to sigma star transition. N to sigma star transition. These transitions are forbidden transition. Forbidden transition. Although this is the forbidden transitions occurs in molecules, because in many of the organic molecules, non-bonding orbitals and non-bonding electrons are present. So many of the organic molecules shows this type of transitions. That's why these transitions are occurring over organic molecules. Okay. Next is UV visible spectroscopy. Instrumental setup. Instrumental setup. Now we discuss about UV visible spectroscopy instrumental setup. So the diagram of UV visible spectroscopy instrument is, there is a light source. There is a light source. light source, and there is this is light source, this is called diffraction grating. Okay, so if it split the light into several beams, and there are present also. This is called slit. Here present a hole. Here only single beam of light can pass. Okay, this is the slit. And the next is rotating disc. This is called rotating disc. There are three parts. This type. Okay, there are three parts. One part is totally black. This portion is black. And this is the three parts. This part is totally black. If the light can fall in this part, so the light is totally absorbed. So there does not occur any type of performance. This is the mirror part or reflection part. This part is reflection part. And this is the transparent portion. Okay. If the light can fall in the reflection part, it reflect into here. If the light can fall on the reflecting portion, it can reflect the light into this way. Okay. Otherwise, if the light can fall in transparent portion, then the light can pass through this. Okay. Here one mirror is present. Here one mirror is present. Okay. It also reflects the light and turns the light into this area. Okay. Here present the sample cell. Here present reference cell. Here present reference cell. Okay. And light can pass through it, and also it. Here also present one mirror. Okay. The light of transparent portion or light of sample can reflect here and go through here. And there also present a rotating disc. these discs are arranged such a way that here the light is passed through the transparent portion, then here reflect and fall here in the reflection portion. If the light pass through transparent portion here, this light is fall here in reflection portion, and the light which fall here in reflection portion and go through this way, here this light can fall here in the transparent portion, and the two lights are go in this way, and here the detector. Okay, so here in this is the diagram of the UV visible instrument. Here in sample cell, the sample can present, and in reference solutions are placed, and light pass through them, and here the molecular lambda max. Now the important features of UV visible instrument. Okay, now the important features of UV visible instrument. In UV visible instrument, there are two light sources are used. One is deuterium lamp, and second is tungsten lamp. Why two light sources are used? Here the deuterium lamp cover the UV region, that is ultraviolet region, and tungsten lamp cover the visible region. Okay, so the first features of UV visible instrument is here use two light source, that is deuterium lamp which covers the UV region, and second is tungsten lamp which cover the visible region. Second, in UV visible instrument, the sample must be liquid. In liquid system, sample must be liquid state or solution state, and the solution must be transparent. So the second features of instrument is the sample solution must be transparent, and the x-axis of UV visible spectrum is wavelength, and y-axis of UV visible spectrum is absorbance. So wavelength versus absorbance can plot in UV visible spectrum. Okay, in the spectrum, the maxima value of the plot, that is the lambda max, can reported. Okay, so no more today. In next class we discuss about some terms like chromophore, oxochrome, hyperchromic effect, exochromic effect, etc. So thank you.